Welcome to Unacademy, the largest online e-learning platform, and welcome to Unacademy semester exams. It's a crash course on circuit theory, and we are in the lecture 7 of graph theory. Graph theory we'll be dealing with. Before that, let me tell you about myself. I'm Vice Shravan Kumar, having 7+ years of teaching experience and mentored more than 5K students for GATE and engineering services and top grade GATE. So let me also tell you about the Unacademy Learning app installation procedure. Just type Unacademy Learning app in the Google Play Store and click on the install. Then you will have Gate and ESC if you're opting for that, and if you have others, you can opt for the other and click on this plus subscription. Then you will have this get subscription page. Just click on it. Then you have both plus and iconic subscriptions, wherein for an iconic subscription you'll get a dedicated mentor for your preparation, and you can also use my code as YSK10 and click on this proceed to pay. If you use my code, you'll get a maximum discount of 10%, and you can click on this proceed to pay. Once you click on this, you'll have payment platforms like debit card, credit card, EMIs, UPI wallets, and net banking. Using any of these platforms, you can make the payments and get subscription to the Unacademy, the largest online e-learning platform. So let me tell you about the Unacademy Combat, which is India's largest fortnightly competition for GATE and best questions by the best Unacademy educators. It's a combat wherein you have the challenging questions curated by our best educators, by the Unacademy best educators, to keep the test engaging and challenging as well as fun. Super fast and fun with real time ranking. See how you rank against the others with a live leaderboard after each question. And compete with the best, know where you stand among all the other contestants in this combat, and you'll have a detailed video solutions by the top educators. Get an in-depth video solutions for the questions right away after the contest, and you'll have the scoreboard, leaderboard, ranking, awards as well. So compete, crack, and conquer. So what are the gives, amazing prizes that you have? As a first prize, you have Apple MacBook Air. As a second, you have Apple iPad Mini. As a third prize, you'll get an Apple AirPod, and top 100 rankers will be receiving rupees 100 Amazon vouchers as well. To sum up, so an academic combat, to sum up, it is India's largest fortnightly competition for GATE. It's challenging GATE questions created by the educators, super fast and fun with real time ranking, compete with the best, and you'll have a detailed solutions by the top educators. So register now. What are you waiting for? And you can enroll for free. It starts on December 16th, 6 p.m. As I told you, you can win exciting prizes, the one which I have mentioned earlier. So let us see. Let us come back to our today's topic. Today's topic is graph theory. Today's topic is graph theory. Welcome Raju. Welcome Soumya. Welcome Karthik. Welcome Shivakumar. Now, let us see what is graph theory today. What is graph theory? It is also called as network topology, network topology, or graph theory. Network topology. Nitish, good evening, Nitish. It is network topology or graph theory. So let me tell you about that graph theory. So let us see what is graph theory. Let's see what is graph theory, or it is network topology. So it's a study of, basically it is the study of network properties by investigating the interconnections, by investigating the interconnections between branches and nodes as well. Right. So this is graph theory. It is a study of network properties, wherein By investigating the interconnection between the nodes and branches, it is a study of that properties of a given network. So next, what you will do is, in network topology, any network is replaced by a graph. Any network is replaced by a graph. And what do you do in that? Each and every line segment, you develop the graph by replacing each element. You replace it by developing or replacing it by straight lines or a curve line. You can say curve, by replacing each and every element by either a straight line or a curve. And you will replace voltage sources by a short circuit. You will replace voltage source by a short circuit and current source by an open circuit. This is what you will do. So network topology is the study of, it's a branch of theory. Graph theory is network properties by investigating, study of network properties by investigating the interconnection between the branches and nodes. And always remember that the number of branches in graph, the number of branches in graph is always less than or equal to number of branches in original network. Number of branches in original network. Let us say you have a graph like this. Let us say you have let me take one example. Let me take one network and I'll try to draw the graph to it. The graph, I'll try to draw its graph. Let us consider one network. Let me consider this network. There is a sinusoidal input here, and you have a resistor, then you have a capacitor, and you have an inductor. Let us say this is an inductor, and you have one more resistor here, and there is another inductor here. Let us say this is the given network. You need not at all bother about these values, L1, C1, R2, L2, V1. Now what you will do is, you'll just mark these nodes. How many nodes are there? This is a reference node. It is also called as the datum node, reference or datum node. So this, you'll just represent these nodes here, and whatever may be the elements, if you have voltage sources, replace it by a short circuit. If you have the elements, replace them by a line or a straight line, and this as the datum node. How many nodes are there here for us now? 1, 2, 3 and 4. You just have to replace this by straight lines. That's it. There is a connection between, let us say this is 1, this is 2, this is 3, and this is fourth node. Is there a connection between 1 and 2? Yes, there is. So you just need to connect it. Is there a connection between 2 and 3? 1 and 2, 1 and 4 is also there. 1 and 2 is also as well present. 2 and 3 and 1 and 4, and also 2 and 4 also connected by an inductor. So 2 and 4 are also connected by an inductor. Then you need to connect 1 and 3 as well. See, this is 1 and 3. So this replacement of these elements by straight lines or the curve arc of semicircle, or the voltage sources by a short circuit and the current sources by a open circuit, is said to be a graph. Is said to be a graph of the given network. Is said to be a graph of the given network. Now let us see the next one. So we have seen what is a graph now. We have seen what is a graph exactly. Varun Krishna, nice explanation. Thank you, Varun. So let us see what is now we have seen what is a graph, and I'll just tell you what are the different things present in this. So this is a graph, right? What are the things that you have to learn is, one is, you have nodes in this. What is a node? It is an interconnection of two or three elements. It is just an interconnection of two or three elements is a node. What is a node? A node is an interconnection of two or three elements or branches is called as a node. Common point at which two or more branches meet together. It is common point at which two or more branches meet together. What is a branch? Then you have to see what is a branch. You will denote nodes by n, capital N, or in some textbooks you will denote it by small n. And you also need to know what is branches are denoted by b. Branches are denoted by b. Nodes are denoted by n and branches are denoted by b. So these are the nodes. These are the nodes and these are the branches. For convenience, I will try to always represent nodes by numbers and branches by letters C, D, E, F. So how many number of nodes are there? You always need to count number of nodes. How many number of nodes are there? 4. How many number of branches are there? How many number of branches are there? One, two. Just write them. A, B, C, D, E, and F. How many? 3 through 6. 6. So number of nodes and number of branches. Number of nodes and number of branches you need to write. So number of nodes n is equal to 4. Number of branches b is equal to 6. Is this clear? These are nodes and branches. Branches are the interconnection lines between the two different nodes or any two nodes in the given network. Hope this is clear for you. Now, branches and nodes. Now, next, we'll see what are the different types of graphs. What are the different types of graphs we have? What are the different types of graphs we have? One is oriented and non-oriented graph. What is that? Oriented and non-oriented graph. The second type of graph is planar and non-planar graph. Planar and non-planar graph. Just we'll try to understand these two. What is an oriented graph and what is a non-oriented graph is, let us say you have a graph that we have taken just now. Let us say this is the graph. This is the graph. Now if you specify the directions of the graph, then it is said to be an oriented graph. Oriented graph is a graph whose branches have been given some directions. So that is the reason oriented graph is also called as directed graph. Oriented graph is also called as directed graph. And if you simply draw a graph like this without any direction, specifying any directions, it is called as non-oriented graph. What is it called as? Non-oriented graph or non-directed graph. It is undirected or non-directed graph. It is also called as directed graph and unoriented graph and undirected graph. Now what are planar and non-planar graphs? So what have you understood now? I have just told you two things. There are two types of graphs that we have seen. One is oriented. What is oriented graph? A graph which has branch directions specified is called as a oriented graph. You have this branch directions specified. You can randomly specify them. It does not matter which directions you are specifying. So this is an example of an oriented graph. A graph in which the branch directions a, b, c, d, e, f, all the branch directions are specified is said to be an oriented graph. Now what is a non-oriented? Now let us see. I told you already this. Once again I'm repeating. So if in a graph the branch directions are not specified, see, you have just a, b, c, d, e, f, you have just specified them. And also nodes, you have 1 2 3 4. You also have 1 2 3 4. So this is called as a non-oriented graph. This is an oriented graph. Now let's see what is a planar and non-planar graph. What is a planar graph? What is a planar graph? A graph is said to be planar if it can be drawn or produced on a two-dimensional two-dimensional paper without without intersection without intersection of branches, without intersection of branches. Let us say you have a graph like this. In this graph you have 1, 2, 3, 4 nodes, and A, B, C, D, E. 5. Number of nodes is equal to 4. Number of branches is equal to 5. Do you have any intersection of these? No. What is a non-planar graph then? What is a non-planar graph? A graph which cannot be drawn, a graph which has intersections. Let us say you can take this, and you also have something like this, you also have something like this is intersection, right? You also have something like this, you also have something like this. Now you cannot draw it without any intersection. Such a graph is called as non-planar, which you cannot draw planar graph, which you cannot draw on a two-dimensional space, which you cannot draw on a two-dimensional space without any intersections, is said to be a non-planar graph. Non-planar graph. Planar and non-planar graph. Hope this is clear for you now. Planar and non-planar graphs. Now let us look at what is subgraph. What is a subgraph? Let us see what is a subgraph. It is nothing but it is just like a subset. It is just like a subset. What is subset? If you have a set like, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If this is a set, what is a subset of this? What is the subset of this? If you take something 3, 4, 5, this is also a subset of this. Similarly, you have a subgraph. What is a subgraph? You have two types of subgraphs. Let me tell you those. There are two types of subgraphs. One is proper subgraph, and the other one is improper subgraph. What is that? You have a proper subgraph and an improper subgraph. What is a proper subgraph? A proper subgraph, let us first, in order to understand this, we need to take one example. We'll take one example so that you'll clearly understand. The same example that I have taken here, I'll just take the same example. Yeah. Let us say this is the graph now. And this is the original graph. This is what? Original graph. This is the original graph. Now let us see what is the number of nodes. Let us denote them as 1, 2, 3, 4, and let us also take it as a directed graph for now. A, B, C, D, and E. So number of nodes is equal to 4. Number of branches is equal to A, B, C, D, E, 5, right? So now what is a proper subgraph is, if you draw a graph, let us take this is 1, 2, and 4. How many number of nodes are there? Only 3. How many number of branches are there? Only 2. So subgraph, a subgraph, a subgraph is, if what is a subgraph? A subgraph is a subset of branches and nodes. Subset of branches and nodes of original graph. A subgraph is a subset of branches and nodes of the original graph. A subgraph is a subset of branches and nodes of the original graph. SVS Online, good evening. Good evening. So this is a proper subgraph. What is a proper subgraph? Is a subgraph that contains nodes and branches less than the nodes, and let us call this as this. Let us take this as N naught and B naught, original, less than the original graph. A subgraph that contains nodes and branches which are less than the nodes and branches of the original graph, it is said to be a proper subgraph. And what is an improper subgraph? Is an improper subgraph has nodes exactly equal to this but branches less than b naught. That means you can take nodes, all these nodes, and just take this. Now if you observe this, it has all the 4 nodes. What is n is equal to 4? What is number of branches is equal to only 3? That means an improper subgraph is a graph that contains all the nodes of the original graph but less number of branches, is said to be an improper subgraph. So these are proper and improper subgraph. Improper subgraph. Now let us look at what is called as Next, let us see some terms like superb explanation. Thank you. Let us see what is a tree, a code tree, twig, and link. Let us see all these definitions. What is a tree? In order to understand everything, you always need to consider what is the original graph. Let us consider this is the original graph for now. So this is the original graph that we have. This is the original graph that we have. And in this original graph, let us take these branches A, B, C, D, E, and F. You can take randomly. I've just taken, if the given question is has some directions, you need to take according to that. Now, what are the number of nodes it has? It has four number of nodes. How many number of branches does it has? One, two, three, four, five, six. Six branches we have. So what is a tree? Tree. In order to define a tree, what is a tree is? Tree is a improper subgraph. A tree is a subgraph. Nothing but tree is a subgraph. A tree is a subgraph which contains all the nodes of the original, which contains all nodes. What is that all nodes? That means it is an improper subgraph, right? It is an improper subgraph which contains all the nodes of the original graph, but no closed path. But no closed path. You can select based on this. So if I draw something like this, let us say this is a graph. This is a graph. This is a subgraph which has all the nodes. Let's say 1, 2, 3, and you have all the four nodes. You have all the four nodes. You have all four nodes. You have all four nodes, but you do not have any closed path. B, C, E. So this is called as a. This is called as a. This is called as a tree. This is called as a tree. It is not that you only have one tree, you have many trees, you have many number of trees. It is not that you have only one tree, you can have many number of trees. So tree is a improper subgraph which does not have any closed path, which does not have any closed path. And let us take this tree once again. Let us consider this tree. So let us say this is the tree. So let us say this is the tree that we have 1, 2, 3, and 4. Now this has A. Now let us see what we have taken in the previous session. I'll just take this to the next slide and try to move from this. So this is the original graph, right? So we'll write original graph. What are the nodes and branches? Branches I'll write. What are the branches in this? A, B, C, D, E, and F. A, B, C, D, E, F. These are the branches. Now let me draw a tree. Let me draw a tree. I'll consider one tree. You can consider any tree. I am considering only one tree. Let us consider this is the tree. And this is B, and this is C, and this is E. Now what are the branches of a tree? Branches of a tree are C, B, B, C, E. And the branches of a tree are called as twigs. Branches of a tree, or the branches that are used to form a tree, are called as twigs. The branches of a tree are called as twigs. The tree branch is called as twigs. And what are these lines? See, let us say these, we have removed these like this, right? We have removed these in order to remove the closed path. We have removed this in order to remove the closed path. So these lines which are removed to form the tree, the lines that are removed to form the tree are called as links. And let us draw what we have removed. We have removed this. Let's take all the nodes. So let's take this. This is one part. This is one part. Yeah. This is the second. This is the third. Now, this is called as the graph formed by the links that are left over, or the graph that constitute the links is called as the code tree. Code tree is nothing but, what is a code tree is? Code tree is a complementary tree. Code tree is complementary tree. Code tree is is a complementary tree. Set of branches which are disconnected to form tree. What is co-tree? Set of branches which are, these are branches, set of branches, right, which are disconnected to form tree are called as co-tree. Is called as a co-tree. So you have understood what is a tree, what is a co-tree. Now let me summarize this. What is a tree and what is a co-tree? A tree is an improper subgraph. A tree is an improper subgraph that do not have any closed path, that do not have any closed path. This is the first one. And the other point about tree is the branches of tree are called as twigs. How many number of twigs you'll have? This you have to know. So number of twigs is equal to n minus 1. It is number of nodes minus 1. The other thing is links. Links. So links is, sorry, co-tree. The other one is co-tree. What is a co-tree? Set of branches removed to form tree are called as co-tree. And the branches of co-tree are called as, and the branches of co-tree are called as links. How many number of links you'll have? Number of links is equal to b minus n plus 1, or you can write b minus n minus 1. These are the number of links and number of twigs. Number of twigs and number of links. You can draw any link, any tree. For example, I'll take one. Mahesh Reddy, hi. Welcome to circuit theory, graph theory concept. See, let us take one graph and try to draw as many trees as possible. We'll also have some expression on how many trees we have, how many trees you can get it. So let us say this is one graph. Let us say this is one graph. Let us say this is A, B, C, D, E and F. Now let us try to draw how many trees, as many trees as possible as of now, and we'll also come across what are the different trees that we have. Now one is that we have already drawn. A tree is an improper subgraph. That means it should contain all the nodes. That is 1, 2, 3, 4. This is one tree, tree 1. So let's take tree 2. Can I draw it something like this? If I draw this, it will be a closed path again. So this is A. So let's name this B, C and E. Here you have A, B, F. Now let us draw one more. Can I draw this? This is 1. You have all the nodes. Say 1, 2, 3, 4. You also have here 1, 2, 3, 4. Everything must be, every node must be connected node again. And this is B, this is D, and this is F. Now just let's try to find number of twigs and number of links expression and do what is this is the expression that is told by me is valid or not. So what is the number of links and twigs? So how many number of nodes are there in this? 4. How many number of branches are there? 6. So what is the expression that I told you for number of twigs? It is n minus 1. What is n? N is 4. 4 minus 1 is 3. So that means number of twigs, number of branches in each and every tree. In this tree, what are the number? How many number of branches? B, C, E, 3 satisfied. So number of twigs is equal to 3. In this also, if you see A, B, F, A, B, F, 3. Therefore, number of twigs. All these A, B, F are called as twigs in this particular tree. Now if you're coming to BDF3, so each and every tree will contain 3 branches and number of links b minus n plus 1. What is b? 6 minus n. What is n? N is 4 plus 1. 6 minus 4, 2 plus 1. For this graph it is same number of twigs and link, For not for all the graphs you'll get the same value of twigs and links. So this is about tree. This is about tree and twigs. With this knowledge of tree, link is also called as cord. Link is also called as co-tree. The link is also called as cord. Just remember, links are also called as cords. So the number of possible trees, you just need to remember this: number of possible trees is equal to n power n minus 2. And this is not applicable to all the graphs. This is a shortcut that generally will be discussed. So now let us see what is an incidence matrix. Let us see what is an incidence matrix. Corresponding to this, we will have to see what is an incidence matrix. What is an incidence matrix? And we'll try to see. We have learned what is a tree, what is a co-tree, now what is a branch, what is a twig, what is a link, number of links, and number of twigs as well. Now, what is an incident matrix is, an incident matrix can be completely explained by an incidence matrix. Completely explained by the help of an incident matrix. It gives the information, the information, this gives the information, this gives the information about, now this gives the information about the branch incidents on nodes and hyphsemi and their orientation and their orientation. That means whether the orientation is towards or whether the orientation is away. So incident matrix is represented by A, and there are two types of incident matrix. There are two types. One is complete incident matrix, one is complete incidence matrix, and there is something called reduced incidence matrix. Complete incidence matrix and reduced incidence matrix. We have two. One is complete incidence matrix and reduced incidence matrix. Let us look at complete incidence matrix. Let us look at complete incidence matrix. Complete incident matrix is represented by A suffix A. So it is actually, what is complete incident matrix is, it is nothing but a mathematical, is a mathematical model to represent, it is a mathematical model to represent the represent given network. It is a mathematical model to represent the given network. It is a mathematical model to represent the given network. We will just see what is that complete incident matrix, and we'll try to find what is reduced incident matrix. So it is represented by, because we are saying it is a matrix, it should have some size, and the size of this matrix is n by b, and the size of this matrix is always n by b. Number of rows represents the number of nodes. This is n by b. It's also n by b. The size of complete incident matrix is n by b, or capital N by b, where n indicates number of nodes, and b indicates number of branches, Now let us take one problem and try to solve how do we get incident matrix. How do we get incidence matrix? And from that I'll tell you, with that information I'll tell you, I will tell you what is reduced incidence matrix. So let us take one problem, the same problem that we have taken in the earlier case. The question is something like this: find or obtain the complete incident matrix for the given graph. Obtain the complete incident matrix for the given graph. So this is the graph. Now let us take this as A, this as B, this as C, and this as D, this as E, and this as F. Now this is 1, 2, 3, 4. Now what is complete incident matrix? AA. What is the size of the matrix? I'll also draw it very big enough. Now how many number of nodes are there in this? 4 nodes. How many number of branches are there? 6. So what is the size of the matrix? 4 by 6. What is the size of the matrix? 4 by 6. Now let's try to fill up this matrix. Then let's try to fill up this. Now what are the nodes? Nodes are 1, 2, 3 and 4 nodes. How many branches are there? A, B, C, D, E, F. These are the branches. Now what you have to do is, now for this first listen carefully. For this node 1, what are the branches that are connected? Just draw them like this simply. And also write their orientation. This is A, away, B, away, D, away. Now, if the branches, if to the node, this is first node, right? How many branches are associated? A, B, D. Except A, B, D, this is A, B, D. Except A, B, D, remaining values will be 0. Except A, B, D, remaining values will be 0 because to the first node, rest of the branches are not touching. So I'm taking the rest of the values as 0. So now you need to write what are these A, B, D values. You have to write what are these A, B, D values. Now, whenever the branch is directed away from the branch, if it is away, write +1. If it is towards, write -1. So this is +1, this is also +1, this is also +1. So this is about first node. Now let us consider the second node. This is the second node. How many branches are there? 3 branches are there. And just take their direction. This is C, away, B, towards, E, away. So whenever you have, so except BCE, that is BCE, except these, the rest of the values are, what are the rest of the values? This is 0, this is 0, and this is also a 0 again. So all the rest of the values are 0, and let us try to write these values. So what are these values? Let us write. So if you look at B, it is directed towards. Whenever it is towards, take it as -1. Whenever it is away, take it as +1. Whenever it is away, take it as +1. Now let us consider the third one. Now directly from here I am telling you A is coming towards it, so it is -1. You don't have B connected to it, 0. C coming towards it, -1. D, you don't have connection to it. There is no D connection, right? There is no E connection either, and F is away, so it is +1. Away it is +1, towards it is -1. If you consider the fourth node, you have all D, E, F coming towards it. So always coming towards is -1, and A, B, C are not connected, so it is a 0. Now in this, the very good thing about that this complete incident matrix is you can easily identify whether you have got the correct answer or not. If you add all the columns, all the column elements, if you had, you must get a 0. If you add +1 -1 0 +1 -1 0 +1 -1 0 +1 -1 0 +1 -1 0 +1 -1 0, this is complete incidence matrix. This is complete incidence matrix. This matrix, this is just for your verification. This is just for your verification. If you have got something wrong, then you should be careful, and you should be in a position to see that whatever you have done is there is something wrong in your solution. So complete this is incidence complete incidence matrix. This matrix is called as complete incidence matrix. So this matrix is called as complete incident matrix. Now let us try to see what is reduced incident matrix from this complete incidence matrix. So let us take this to the next page. Yeah, this is complete incident matrix. Yes, I think you have got it. This is complete incidence matrix. Now from this you need to find what is reduced incidence. इसमें से क्या फाइंड आउट करना? reduced incident matrix फाइंड आउट करना इसमें से. So reduced incident matrix, if you want to find what is reduced incident matrix, is it is denoted by A and the matrix size is n minus 1 by B. That's it. That means you need to remove one row, or in other words you can say consider one node as reference node. Consider one node as the reference node. So that means you can take A is equal to any one row that you can consider as the reference node. So I'll consider one node, the fourth node, as the reference node, because I'm assuming the graph is something like this and fourth node is connected to ground. I am assuming something like that. So I can eliminate it and write plus 1 plus 1. The rest of the values remain same. 0 minus 1 plus 1, 0 plus 1, 0, minus 1 0 minus 1 0 0 plus 1. So this is called as reduced incidence matrix. This is called as reduced incidence matrix. So we have seen what is complete incidence matrix and also what is reduced incidence matrix. Complete incident matrix and reduced incidence matrix. Also, if you can look at this, you have two. One is AA, which is complete incidence matrix, and A, reduced incidence matrix. Hope this is clear for you. If you have any doubts you can ask. So you have complete incident matrix. The size of the complete incidence matrix is n by b, and the size of reduced incident matrix is n minus 1 by b. N minus 1 by b. N minus 1 by b is the n minus 1 by b is the size of the reduced incident matrix, and n by b is the size of the complete incidence matrix. From these two information you can write one thing, that is number of possible trees is equal to data of A into A transpose. This will give you the information about the number of possible trees. For a graph you can draw many number of trees, and it is also limited. So this is nothing but the expression for, or the formula that you have to use to determine the number of possible trees, the number of possible trees for a given graph. Now let us take one example. Let us take one example and try to find incidence matrix for one question. So the question given is something like this. Let us take one question and try to write. Yeah, let us take this question. There is some question given like this: construct the incidence matrix for the graph shown. Construct the incident matrix for the graph shown, and the graph is something like this. It is given something like this and like this. There is another node. We'll just try to draw it little bigger. That big, that makes sense. This is one, this is the other, and this is the third one, and this is the last one. This is given to us. So if you look at this graph, there are three nodes, and it's also given in the question as 1 2 3, and the directions are also specified. This as A, B, this as C, and this as D. So what is that question? Construct the incident matrix. You can construct a full complete incident matrix. So let's write first complete incidence matrix. Complete incidence matrix. Let's take complete incident matrix. What is that? A. How do you write that? Need to take this matrix. What is the size? So for this, what is the number of nodes? 3. How many number of branches are there? One, two, three, four. 4 branches. So how many nodes you'll get? One, two, three, 4 nodes. You'll get it 4 nodes. You get 4 nodes like this. This is one, two, three, 4 nodes. Nodes by branches. So nodes by branches is this. So this is A, B, C, D. 4 branches. Now let us take 1 to 1 which are connected. A and B are connected. When A and B are connected, when it is towards, it is always -1. So A is -1, B is also -1. C and D are not connected. Similarly, if you take second node, A is moving away +1, B is not connected 0, C is also moving away +1, D is also moving away +1. Now let us take node 3. B is moving away, so A is not connected, B is moving away +1, C is coming towards -1, D is also coming towards -1. And if you observe the columns, see, if you look at the summation of these columns, they are all zeros. +1 -1 0, -1 +1 0, +1 -1 0, +1 -1 0. That means the answer that we got is perfect. The answer that we got is perfect. And what is the size of this matrix? And what is the size of this matrix? It is 3 by 4. You have 3 rows and 4 columns. What are the columns that denote? Columns denote branches and rows denote nodes. So you can write it as, you can also write it something like this here. Yeah, you can write this as here, nodes by branches. These are branches, these are nodes. So this is the complete incident matrix. Now if you want to obtain reduced incident matrix from this, you can obtain A is equal to, what is A is equal to? You can write 1 1 2 3. So it is -1 +1. So you do not take, it's not fourth node, you don't have fourth node, you only have 3 nodes. So this is 3 by 4. So 1 2, you can only take 2 nodes instead of, because you need to take 1 as the reference node. So -1 +1, -1 0, 0 +1, 0 +1. So this is a reduced incidence matrix. This is reduced incidence matrix. You don't have fourth row here, you already have 3 nodes because you have only 3 nodes. So you can take this node as the reference or datum node. You can take this as the reference node or the datum node, and you will get a reduced incidence matrix. You will get a reduced incidence matrix. So this is how you will find reduced and reduced incident matrix and complete incidence matrix. So you can also see the one more in the reverse way. You can also do, what is it is, so construct or draw the graph from given incidence matrix, from given incidence matrix. This can be the one question that can be asked generally. Now let us say there is a graph, there is a complete incident matrix given to us. Let us take one big complete incidence matrix like this, and I'll write the values. Let us separate them one by one. One, sorry, two, three, four, five. How many numbers? Six are there. One, two, three, four, five, six. One, two, three, five. The last one, six. So let's try to take this off and draw it something like this. Let's also try to draw this a little good. Now let us take this. So let us also take some rows also here. That's better. One, two. How many are there? One, two, three, four, five. One, two, three, and four and five. So let us mark them. Let us call this as first node, second node, third node, fourth node, and fifth node. And let us call these branches as A, B, C, D, E, F, and G. Now I'll write these values. The values given are -1, +1, 000, 000. Then you have 0, -1, 1, 1, 0, 0, 0. Then you have 0, 0, 0, -1, 1, 1, 0. Then you have 0, 0, 0, 0, 0, -1, 1. Then you have all, sorry, then you have -1, sorry, +1. This is +1, 0, -1, 0, -1, 0, -1. Now from this you need to draw a graph. Now how do you do that? That is very important. When you have, first thing that you have to do is, you have how many nodes are there? 5 nodes are there. Just mark those nodes. So let us take these nodes as, this is 1, and this is 2, this is 3, this is 4, and this is 5. Generally take one node as the reference node, and rest of the nodes either in a series, in a line, or one up and one down. Thank you so much, sir. This is very useful. Thank you, Jayant. Now, let us look at how do we do this. A. If you are looking at A, the branch A. See, as I told you, when it is away, you have to remember this. When it is away, +1. When it is towards, it is -1. So when a branch A, you have to look at the branch A. Branch A is at first node, it is -1. That means it is going from first node, and where it is going to fifth node. So let us mark the nodes first. So this is 1, 2, 3, 4, and 5. So now branch A is between 1 and 5. First, just branch A is between 1 and 5. Simply branch A is between 1 and 5. Now branch B, it is between 1 and 2. It is between 1 and 2. Now let us write these values also, else we'll get confused. So it is branch A, and this is branch B. Now let us see branch C. It is between second. See, 1 is at the second, and -1 is second. And so this is branch C. So let us write this branch C. This as branch C. Now D is between 2 and 3. D is between 2 and 3. So D is between 2 and 3. So just take it. D is between D. So this is D. It is D. Now D is between 2 and 3. E is between 3 and 5. E is between 3 and 5. Between 3 and 5. Between 3 and 5. See, E is between 3 and 5. So E is between 3 and 5. E is between 3 and 5. So E is between 3 and 5. This is E. Let's not take this directions as of now. I'll just erase them. Better to erase these. This is the direction that you have to, yeah, take a smaller one and try to erase this. Try to erase this. Try to erase this. Now E is between 1 and E is between 3 and 5. E is between 3 and 5. Now let's look at what is F. F is between, if you see F is between 3 and 4. F is between 3 and 4. Just draw a line. F, this is F is between, and G is between 4 and 5. G is between 4 and 5. So this is G. So this is G. Now let us try to mark the directions. Now let us try to mark the direction. The first thing that you have to do is first see where is A. A is connected between, either it has to be +1 or -1. Either it has to, see, if you observe here 1, you have -1. That means it is at first node. It is touching first node and fifth node as well. So you have these two. And if you observe A, it is -1 at 1. -1 at 1 indicates it is coming towards A. And if obviously at fifth node it will be +1. Now if you observe B, it is 1 at first node. Positive at first node means it is leaving the first node. Now if you observe D, wherever it is +1, 2. So it must leave. D must leave second node. This is the second node. Now E is must leave the third node. E must leave the third node. And F must leave the third node. F must also leave the third node. G must leave the fourth node. G must leave the fourth node. If you see fifth node, it is minus 1. Obviously, it is entering. So if you observe C, C is plus 1 at 2. So it is also leaving. So this is how you will obtain a graph from the given incidence matrix. This is also very important. In one of the university examinations, this question was asked. So this is all about today's session. We have seen what is a graph and what are the different types of graph, and also I told you about tree and co-tree along with the twig and link and their formula, and also we have seen what is incidence matrix, and also we have seen what is incident matrix. So we have India's number one study channel, Creatrix, Unacademy, Unacademy Gate, Unacademy Computer Science, Unacademy Gate, Unacademy Gate Questions, Unacademy Gate Telugu, Electrical Junction, Unacademy Foundation, Unacademy Pathshala, Unacademy Semester Exams. So please do like the video, share the video, use my referral code as YSK10 to get maximum discount of 10%. Subscribe to our channel and click on this notification bell icon to get notification of my classes. Thank you once again for joining me today on this beautiful session on graph theory. Thank you all.